Okie dokie. So how did the homework go? Wasn't bad. The program you're using here? Bracket. Okay. So homework was to update our let expressions to allow for a let inside of a let. And really, you don't even need to allow for a let inside of a let. You just have to accept the fact that you may have the body of your let may be another let who might have a body of its let be another let, and yada, 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 which means we need to make sure that let's now use our scope-based environment and not the old blah, whatever. Okay, so I know we had a bunch of functions for lets, but let's just go and look at how lets currently work. Nope. Deal. What's that? All right. All right. Well, now I'm lost. What was I doing? Oh, well, that doesn't help me. It doesn't help me at all. Ah, let expressions. All right. So in our let expression, we had our var2 lists. We had an environment let mapper. So I want to display what a let looks like. So a let in our language, here's my parser. Called local vars. Okay. And then it takes, have we created, I know we had our grammar for our language. Have we updated that anytime soon, anytime recently?
I think we updated it. We made call expression. Yeah, we call expression now.
Okay, but we don't have lets in here yet. All right, so after call expression, we have a let expression, and we did that as local vars. Is that right? Is that the right word again? I'm lost again. Oh yeah, local vars. All right, and so local vars, it took what, a list of two lists? So something like identifier, no lang expression.
As of right now, I believe it only supports.
Really?
Instead of a no.
All right.
It doesn't actually pass the environment.
This is like a crappy design. Actually, no, this is your language. All right, we'll come back and update that shortly. So this is just a number now. Well, actually, I probably just want to say this. So is that what the? All right. So local bars, identifier, number, null expression,
Is that as this is like,
0 or more. That's called, I think we had mentioned it. Do you know what this formal syntax is called? When you put an asterisk at the end of it? Well, that's what it means. What is it called? If you were to called a cleany star format. You heard that before? KLEENE.
the name that
I think so.
guy in the general.
You say it could be after a woman? I think that's highly unlikely. Well, that was our theory the other night at the house. We were using the brain computer interface thing. Did I tell you that I couldn't get it to work? So we got this thing that goes on the back of your head, and then you have to train it. And so you're supposed to concentrate on this like circle that has these little green lines that kind of go into like a triangle, and you got to make them go into a triangle. Make them a triangle. And I couldn't do it. My wife gets in there and just nails it, like no problem. You know, she gets like a 3 out of 5 score the first time, and then just aced it after that. You know, once you figured out how it was working, I couldn't get anything. I couldn't get any score. Like I just couldn't do it. So in the end, we just decided, you know, obviously primitive brain. You know, didn't have to. Well, her suggestion was because of my autism, I'm like 99% left-brained, and I don't really talk to the other side of my brain, and the thing hooks onto both, and so maybe there's just not a lot of crosstalk. Yeah, you put it like a headband. So it's kind of like a hockey puck thing, but on the back of it, it has just like a bunch of little like knobs.
Oh, I get that now. It's probably with your
Yeah, because it seems to be very related to vision.
yeah, that makes sense.
You know what I didn't try that I should try? I should try putting it off center. Just on the left side. Huh?
I thought that was.
And that's what I'm thinking.
If it's with your because that's like right here.
If it's using a specific part of your brain that needs to be as close as possible.
Yeah, but I don't have function on the other part of my brain.
Yeah, but well, that's why it didn't work.
That's exactly.
If it didn't
So I
work,
need to
it's
move it to
probably
the side that I have function.
If it didn't work, it's probably not gonna work.
Oh, we're not very supportive. I actually looked it up. It's something known as BCI illiteracy. Like apparently like 20% of the people, depending on which BCI technology you use, it just won't work on you. Yeah. All right, so right now we just have identifier numbers. We can have as many of those as we want, and then we have the body of this guy, which is a null expression. Is that the correct syntax? Okay. So let me save this so I don't forget. So I should be able to go in here. Local vars. A2, B3. What's it do mathy stuff? Plus AB. Is that legal code? All right, just want to run that real quick and make sure everything's zigging when it should be zagging. Or zigging when it should be zigging.
You're not like this building everywhere. You're trying to get
What do you mean it's not functional to run yet? I haven't written a nested. I just wrote local vars.
no, it's broken.
What do you mean it's broken? It didn't work to begin with?
No, it worked to begin with, but you changed ExtendEnv.
Oh, I get it. I get it. This guy no longer is a thing.
It's still a thing, it just doesn't take 3 parameters.
Who? It says that it doesn't take 3 for every 629. What's ExtendEnv? It takes the scope and it takes an environment. So I got to pass it the empty scope. And then the current environment. Let's see what this guy here. Let me just get to my error again. All right.
Or the cat or a Parse no code is
So here's our variable to list. So that is our current scope. There, let mapper. I want to look at the parse no code here. All right, so we have a let expression with a list, with a couple of different things, and then our, okay. So I want to get these guys, which that's actually a scope already, right? And that's going to be my new local scope. So I want to call extend, well, no, because I don't really have that. I'm just going to make myself, even though it's not really necessary, since we're looking at this and we're saying this is already a scope, this list of to lists, this is what a scope looks like, correct? But for right now, I'm going to have a function called build scope that takes a list of to lists in and just returns that value. The main reason being that we're effectively in code then labeling it as a, I'm building a constructor for a scope, and this particular structure constructor takes in something that's already a scope and just returns it. Just so I'm labeling it as what it is. All right, so I'm gonna define construct scope via Lambda. It's going to take in a list of to lists. And for right now, since that's what our scope is, we'll just return list of to lists. All right, so we want to construct the scope out of this, then extend our environment with that scope. So what's our environment let mapper doing? We need that. Yeah, here, I'm just going to gut this. We'll just rewrite it. It'll be easier that way. Okay, so I have something that looks like this. So I need the list of, so the car of the cooter will give you my list of to lists. So we're going to call this guy a, so scope. Let's call it new scope. is going to be construct scope out of the car of the coder of parsed no code. All right, so that'll give me my new scope. And then what do I do with that scope? I need to extend my environment with that scope. New ENV is extend ENV with new scope and my current environment, right? All right, and then I'm gonna go ahead and grab the body of my let expression, and the body of this let expression is the car of the coder. What's it called? Parse no code. And then I will run my body in the new environment. Like that looks good, except we need to finish with some parentheses stuff. Wait, no, we're good here. So now this guy should run. Okay, so that is our, well, actually, I think we're done now. That's the homework. Because now I can go in here and I can create a, I'm just going to steal this. I'll give myself a more local version of A. So this should be 4 plus 3, which is 7. Let me make sure I have parentheses in the right place. So that's the body of that local vars. So the body of the outer local vars, and this is the body of this inner local vars. All right, so this should give me a 7. All right, so that's the homework. Well, that's not going to work based on what he said, that it's our code doesn't currently allow you to have var expressions or no code expressions. Because it's not actually calling, although isn't that what our mappers did? I just can't believe I wouldn't have done that. I mean, even if you thought we should have a stupid interpreter.
I know I want to fix that.
Where are the, aren't those up by like? Where are we using these right now?
So those were used in environment web mapper, and environment web mapper would take in a list of two lists, I believe. It would take in one list, two list, and it would grab the first value and the second value. Something, I don't know.
Right, because of the.
Oh, because our old version of the environment, we just put those guys in the front because we had a single flat global environment. So these guys aren't even things anymore. We're not using them anymore, right? We're going to find out real quick. Yep, we're not using it anymore. All right. So to her point, let me just quickly do this. I think this is the solution to the homework given our current interpreter. Well, here, let's just show the error that she wants it to work a certain way, which is the better way. So let's just be honest here. She wants you to be able to set A equal to B and get a value of 6 out of this. Well, the problem is right now our let expressions, they won't call, they won't run that code. They won't turn B into its thing. Yeah, so it's trying, yeah, here's the symbol B, do some math with this crap. Okay. But now actually what's interesting, I want to turn this back into what I have it as a 4. And I want to show my parse no code again. Oh, I kind of hate that. Because what you need to do now is we need to make sure that we're running this through the parser. Because right now it's just assuming it's a number. And since we assume it's a number, it's not going to be hard to fix. We'll fix it real quick. But let me just give you, this is the solution to the homework currently. Unless you wanted to do it, let's say the right way and have it allow expressions, but you know, whatever. Nobody's perfect, especially not this group. I was mainly talking about him.
Solve this, because I did this in my vowels, let that go, vowels thing.
Are you saying vowels?
Vowels.
Okay, like A-E-I-O-U, but vowels?
Bars and vowels.
Oh, vowels. Okay, gotcha.
Could you check if it's a number and if that symbol, if it's a number, if it's a symbol, run it through.
Well, the answer is yes, but what if it's a do mathy expression?
Then it's not a number or a symbol, run it through your parse.
But if it's a symbol, don't you want it to still go through parse code to give you a var expression? Well, you could, but isn't that what, I mean, in our, here, let me just do, what homework was this? So if I go into my run code here, what do we do for a var expression? We call resolve. So why would you want to resolve it someplace else in your code when you could just say, look, whatever this dude is, I'm going to make it a no code expression. If it's a numlet expression, it just boils down to the value. If it's a var expression, it resolves it. If it's one of those other things, it does its thing.
So you're going to add those things to the front of your.
Well, no, when I get my values, and I might put this inside of that build scope. I'll have to see how the spirit moves me in a second, I guess. But what I'll have to do is when I have my list of two lists, those second values there, I can't just assume those guys are, oh, it's a map.
Anyway,
Yes.
the first value always
A symbol. First value is always the name of a variable, but the second value in that to list is the value of that variable, which right now our code assumes that's just a flat number. We're not resolving, we're not doing anything with it. It's just a number. But we want to say, can't that just be anything that's an expression in our code? It could be a lit expression, which would be a number. It could be a var expression. It could be another let expression. If that was something that we wanted to do, it could be anything, right? It could be a call expression. That was a function that boiled down to a value. All those things should be reasonable, right?
So at what point in the code would you want to parse and run?
Okay. Well, the starting point here is we need to go make sure we update our parser so that when it's building our parsed version of a let, it parses the second element of each of those two lists.
Would it have to do that with a global environment?
If you wanted to make it work on a global environment, you would have to do it. Were you the one who asked the question in Slack? Somebody asked that question to me.
I asked it yesterday.
Okay. Oh, in my office. Yeah. So the idea, so what he's saying here is, well, remind me to come back to that after I do this first part. Okay. Otherwise I'm kind of talking in the sky and certainly he's lost.
We're all-
That's what makes my day. Every single Tuesday and Thursday I show up and I just see this This level of deer in the headlights. It actually works better than the coffee, to be honest.
I think you could do 200, it's probably just as bad.
Especially since we're doing pointers in there right now. Well, but think about how easy pointers are for you now.
I didn't use them at all.
Now, what's the pointer again?
You're actually probably serious. Do you really want to know?
No,
Because you don't want to embarrass yourself in front of your friends. All right.
Yeah, I was gonna say at this point, I've already made people that voted for.
But it actually isn't.
Yeah.
It's just different than the way you actually solve problems in real life. So it's foreign to you.
Yes.
And the more you practice it, the more you realize the stuff you used to find hard was actually trivial.
Yeah.
I'm telling you, this stuff will help you.
Oh, no, I'm well aware.
Yeah. What do you mean? Is this how I solve problems in real life?
Solve problems in real life.
Kind of like what we're doing here? Absolutely. I mean, here's the example. I don't remember when this was, but how many of you were following me when I was on a cruise several years ago and I wrote that program in the chicken language?
Oh, I was the one who gave you the chicken language.
So the chicken language is a ridiculous, stupid language because it's kind of like assembly language where each magic trick is some number of chickens. So I wrote an interpreter so I can write the stuff I wanted to write and it would turn it into chicken. Then the code was easy to write. Voila, real life problem solving with this crap. So I'm sitting at a bar on a cruise ship writing an interpreter for chicken language. Yeah.
What about real life at a company?
Well, same thing. Let's say they give you a new tool that you're expected to work with. And let's say, okay, well, this isn't the end of the world, but this is kind of cryptic. And if I'm writing this directly, if I'm natively writing, let's use my example of chicken language. It's not hard, but it would probably be in my best interest to have like an Excel spreadsheet with a bunch of the things with the number of chickens next to it, where whenever I wanted to use it, I would go and copy that cell and bring it in there. It'd be error prone. So you might say, okay, well, rather than be productive in this new language, which maybe you decide, hey, this is going to be error prone, you might say, well, I'm going to go ahead and I want to write code in a way that I'm already used to, that I'm less error prone with, but I want to make sure it converts to the code I need it to convert to. So you might write your own interpreter that maps between a language that you're familiar with, which presumably your coworkers are also familiar with, to this new tool that maybe the company is expected to work with. Maybe it's a scripting language for some new software the company got. But now what did you just do? You didn't just build a tool that makes you more productive. You now have a tool you can share with your coworkers that can also make them more productive because they don't have to actually code in this new tool language. They can just code in the old language that they're used to because it maps to the tool language now. At the end of the day, you're building tools. Just goes all the way back to Home Depot. You need a hammer, go buy a hammer. In this case, we're building the hammer. Unless there's already an API for the scripting language where it's like, you know, C to chicken language. And then you just go and get that. You buy the hammer instead of build the hammer at home. I'm telling you this. So this stuff is interesting stuff. And just because something sounds ridiculous or sounds like something you never use, you'd be surprised. All right, so you want something like this to work, right?
Yeah.
For example. Okay. So right now, this isn't going to fly. I'm not going to run this. We'll just look at the parse code so I can show what I want to do here. So right here in this innerlet, we have list A, B. We really need this to say var expression B. So we know to resolve that in our current environment. And what's going to come with that, and a side of fries to that, is this is a lit expression and this is a lit expression. So effectively, what are we saying? In every single toList, we will have our variable name, and the second element is going to be upgraded from the way it works now, which is just the number, to something that is a no-code expression that can resolve potentially to a number, but also potentially more. All right, so we want to go ahead and update our parser to make this guy work most bestest. That's right, grammar, right? Yep, perfect. Nailed it. Where's my parser? Where's my let? So this is the toList, or is that the list of toLists? So I'm probably going to build a helper function for that. No code, let ENV parser. Let's call that good. And this is going to take in a list of toLists, right? I just want to see what that looks like. Not that I don't believe you, but I don't. Actually, I do believe you. I just want to see it. So that's going to be right after the word let expression. Actually, we already saw it, didn't we? It's the thing right after the let expression. That's what it is. All right. So it's stupid not to believe you, to be honest. All right, you get a star for the day or something. What's up? Have you ever had a star? All right, so now we're going to use map. So what are we going to do? We're going to map. Oh, this is going to be so good. No, I actually need a lambda. I'm going to map a lambda that takes in a toList, and it creates a list out of car toList and no parser on the cooter toList. Yeah, but it's not what I want. I want that. So I did want the category. And I'm mapping that across my list of toLists. So now I have my A is equal to a numlet expression, B is equal to a numlet expression, A is equal to a var expression B. Right? Okay. So get what we did there? That was not a hard map, right? Did everybody follow this map? I'm mapping. So what does map do? Map maps a function that takes a single parameter across a list and applies that function to each element of the list. The list I'm passing it is a list of toLists. And what am I doing with this function? I'm taking in that toList. I'm building a list whose first element is the same as the first element of the current list, but whose second element is the result of calling no parser on that second element. So I'm making sure I'm parsing the value associated with this variable so that later on I can actually execute that code and get a value out of it. All right. So I got that. So my no parser now is doing its job. So it's putting our lets in the correct format. Good.
Do you want the parameters that get added, in the call expression? You also have to run for them?
Probably. But let's what he's are we positive it doesn't currently? Okay, just treat them as numbers. Okay, so our next step is going to be for the exact same reason. Our call expression right now, remember, what does a call do? A call calls a lambda and passes it the inputs. Well, right now we assume our inputs are always numbers, when it's not unreasonable to say, I assume my inputs are the result of a no code expression, which could be a number, could be a lit expression, which boils down to a number, but it could also be a var expression or one of our other thingies. No, we'll look at it. We'll finish the let first. All right. So we're going to look at this and say, okay, this guy looks like it's parsing correctly. So now we need to go and update our let in the interpreter to make sure it executes this correctly. All right. Run parse code. Here's my let. So right now, when I call construct scope, I'm passing it this list of 2 lists, right? So maybe what I'll do is inside of construct scope, I can go ahead and pass that guy the environment. So I'll add another parameter to my construct scope. It's gonna be okay. One limitation to this. We have to decide how we want it to work, because I can say A is equal to B there, but what if I want to say that C, well, that's fine. C is equal to A. Inside of that same level.
Does let star always do that?
Let star would let me do that, but right now our let doesn't work like a let star. Our let works as a let. All right, so this is going to make it work as a let where this would not be allowed. Actually, it would be allowed. It just will read off of this A. C will be equal to 2. It won't be equal to 3. Where I probably intended for this guy to, here I can say C is 5, D is equal to C, something like that. This will break. Because now I'm going to say, I'm going to create a new variable named D, and I want it to be equal to, well, it actually won't break because I have a C in there. We're going to say R. I don't have an R in my global environment. Okay, good. So no R in the global environment, no R in this first local vars, the second local vars. I'm defining an R here, setting it equal to 5, and then I'm trying to define a variable named D and setting it equal to the value R. That will not currently work. Because when it is resolving these guys, the direction we're going with this, it's going to resolve in the environment it currently has available to it, which is going to be the environment where this is the most local scope, and this is the next most local scope. That is, it won't know that I have already defined an R inside of the scope I'm in the middle of building. Yeah.
So it wouldn't break, it would just set the
Which will then not resolve.
That's what-
Yeah, correct. The parser wouldn't break. Yeah, it would be that when we run it, it's going to say, look, you've false here. Hope this works out. I'm going to give you a false for the resolved value of R. And I think that's what resolve currently does, right? It returns a false if it can't find the value. All right, so local vars as of right now works like a normal let in Scheme, which is fine. We're going to say that that's okay for us right now, but that will be a limitation that we're about to continue to have after we finish writing this piece. Okay, so going back up to run parse code. When I build my new scope, I'm calling construct scope on my list of two lists, but now I know that I need to do something extra to that second value of my list of two lists, or the second value of each two list. And in order to run that second part, I'm going to need the current environment. So up here, when I construct my scope, I'm going to also take in an environment as a parameter. But now I need to do something to this list of two lists. Might as well keep it there. And I'm going to map a lambda that takes a two list as a parameter, and it produces a list out of the car of the two lists, and run parsed code on the catter of the two list in the current environment. So I'm going to map this function, a function that takes a two list and returns a two list whose first element is the same first element as the previous one, but whose second element is the actual executed code of the parse no code that is the value of that guy in our current environment. And I'm going to map that function across all my two lists. All right. So now, am I doing what you wanted me to do? The A will be, so this should give me a, yeah, 6. I think this should just work. Oh, I'm not running my code. So there's our 6. But this then also lets me do something like do mathy stuff. Times A3. So if A is now a 2, 2 times 3 is 6. Let's make it 4. Make it an 8, so we get a different number we just had. So A is now 8. Then we're going to say A plus B, so 8 plus, that's going to give me an 11. So it doesn't just have to be var expressions. It could be any kind of expression from our language now. That could be the value of this guy. All right, that makes some sense. All right, and then you wanted to look at call expression.
It already does work, but I don't think it works.
Who?
Call expression. Because the environment isn't part of it.
I bet you I could say that the rest of the semester. You guys will keep cracking up. What, the who thing?
Yeah.
Oh, because I've been saying it for years. Is it an inside joke inside your group?
No.
Oh, I see. Really? Like you may feel differently when you get to the final.
They actually Big sock, you can say less.
I think I told you guys this before, but you've heard me say that phrase "suck less" for years, right? And I never saw it on a shirt or something like that, but it's now on shirts and mugs and. But this is what I didn't know that, and so from Aurora WDC. So hopefully all of you went to the Tech Talk when Eric Johnson was here. The very first time. Actually, it was the second time I met him. First time I met him was outside the makerspace. That's when we first met. He was touring campus. So the second time I met him, of course, was at a bar. And he was wearing a t-shirt that says "suck less" on it. And I got a picture of it somewhere on my phone of that. And I made him promise to get me a shirt that fit me that said that. And to this day, he hasn't done that. No, I remind him often. Yeah, and I'm actually seeing him tomorrow at a bar. So see, there's like a trend here. It's kind of the problem.
So what if I made you a custom suck less?
Well, what size do you think I wear? 2X? Okay, you couldn't handle my midriff. if I'm in a 2X. That's like the Hulk shirt. Like after Banner turns into the Hulk and he's just got the shreds. Still pretty close to the shredded shirt. I'm thinking at least belly buttons out. 5X will do it. 4X tall is probably my official size. I usually buy 6Xs because they are taller. So like this is a 6X. And I have to go to a canvas guy who does that stuff. So he gets the material, and I have to go to his farm where he cuts all the material. Well, it's actually a funny reality of how, at least American society, we've become more and more obese as a society. The easiest way for me to get clothes that fit me is Amazon. And it's always on sale because nobody else is buying it. You know, I just have to do a little math because, like, when I'm buying pants and I have to put the waist size in, I got to do it in scientific notation to get it to, and they only give you so many decimal points. It's a thing. I had to call Amazon's tech support to have them expand the input fields. Like, look, you're asking for an answer, you're not giving me enough room to give it. Ooh.
That being said, I think stores should have. I think that could be the target for stores.
Yeah, but they can't. They're not going to be able to do it. That's another hobby of mine, is just walking into some like men's warehouse. You know, it's like, let's find me a suit. And I think it's going to work because they're thinking 2X, 3X, or whatever. And it's not just that I'm big. I'm like super tall and stuff. I'm just this huge human. I just don't see it at first. I seem petite. But in real life, I'm quite large. That's the thing. What's up? Small on the phone. Well, yeah, but you got to find a provider who has, or you got to get like the logo somewhere and get it embroidered on a shirt that fits me. Or I could get it as a tattoo.
Well, that's where it goes like, that's where it goes with I don't know if this could hurt to do this, but like just order like one customize a suck less t-shirt in order to double 5X.
Yeah, right, you could, if you put up the, got the logo, put it up there, you could do it, make it work.
You should do stuff less than
Do you have enough? Wait, hold on, do you have enough? So 4, 4, 8, so then I can, I could put like a couple exclamation points at the end. Actually, no, you wouldn't need it, you just need knuckles. Oh, it'd be perfect. That has to happen. I feel like that has to happen now.
You have to, but we were right.
Well, this is already like a plastic ring.
Yeah.
I could just get the ring tattooed on. That could be the bottom of the tattoo.
Yeah.
Oh, we have solved the world's problems today. This is great. I don't think my wife would let me get a tattoo, but for that, maybe. Because that's like a productivity tool. Read the fists. Who? That's going to be question 11 on the final exam. Just who with a question. All right. So I believe what I said, that he said a call function already works that way, but we did it a different way.
I don't know how we did it, but I just put that, stuff and did the parameters.
Oh, so you know it works a different way just because you tested it.
Yeah.
You didn't look at the code?
No.
What kind of programmer are you? All right, here's our call expression. Oh yeah. So here's our no code. Here's our no code. Well, what does a call expression look like? So we're calling our function parser here, which is fine. So a call expression is, this is, I'm in there, no parser. And then we're calling our function parser on just the function portion of it. And then we're mapping no parser across all the values that are being passed in. All right, so that's how this guy is doing it here in the parser. So we are calling no parse on all those parameters. Now let's look at when we call it. That's in or else, right? Call Lambda code stuff, LOL woot. Yep. Oh, so good. All right. What'd you say? What? Just all of them. All right, so for our run parsed function code, we're going to pass it the function that we want to run with the extended environment, where we're going to pass it our extend scope of our, these are our variable names, list of variable names, right? And then, so actually here, we're gonna make this look better. List of var names. And then we're going to have our list of var values. That's going to be this map thingy. Don't be a coward. Nobody likes a coward. All right, so we're going to extend our environment with. Hold on, I have the wrong closing thing. So I'm going to extend my environment with this scope, which is no different than what we had before. I just went through here and I labeled the list of variable names and the list of values. So now when I call extend scope, this looks a lot cleaner. It's the exact same code. Okay. So I'm going to extend our environment with this new scope built on top of the empty scope, along with the pop to global of our environment. And what am I going to do with that? I'm going to run the parsed function, which is our let function equal this guy. So I'll run my function inside of this extended environment. So my let, this outer let, I'm just going to extract the function part of it. And all we're doing with this let is we are labeling what this crazy thing does. Otherwise, we look at this catter and we just say, okay, well, what am I actually getting from that? Can you even think about today? You know, I'm asking the question, well, what value is this? And I'm having to print out the parsed code to go and get that. So if we can start labeling that in our language, it makes it easier to work with later on. All right, so I'll extract the function, and then I'm going to run parse code on that function. We'll run parsed function code on that function in this extended environment. I'm missing a close. Just want to make sure I have that in the right place. That's the end of that let body, or the let variable list. That's the variable list. Here's the body of that guy. Here's the end of that variable list. Here's the body of that guy. Here's the else. That's the cond. That's the lambda. Okay. So I just put it there at the end. All right. So in this case, I can say function A age. So age will come in as A. Age is a global variable here. So if age is 21, A will come in as A. And I'm going to call function R on, which boils down to A, which is going to be 21. So I'll run my sample no code. Well, it might actually be right. Hold on, let me make sure. Yeah, because it is a var expression. So I'm passing in A for R. But hold on. So I'm calling something. Oh, wait, that's my function. Here's the value I'm calling. A is coming in for R. But in this outer function, I'm setting A equal to whatever age was. Oh, that's right. That's right. So this guy doesn't get this inner guy's A. It's working the way it's supposed to work. Got it. So if I put in age there and I put in 5 there, then we get our 21. Because we have that inner, well, what is my R? Oh, yeah. That guy. Or I could have just put A there. There's my 21. Or I could have said A there, which would give me my, well, it's already giving me my 7.
You think that R is-
Because now I'm creating a new local variable, age bound to A. All right. Okay. So let's put this code up on Slack. Here's the Chickenpedia. The homework for Tuesday is to read that and write a 2-page paper explaining what it says. Is it written in Chicken?
It's written into it.
which is Parser.
Oh, sure.
I get,
Is it closet or just that side? Yeah. Is that funny enough? I won't give it to you. But funny enough, this would be an appropriate assignment for this class
I know it would be.
because this is your input language. You would then need to parse it into, you could write a parser that turns this into, you'd have to look at the functions in the chicken language, the definition of the chicken language.
Well, this is what the chicken language is based on. So this is maybe for the chicken language.
Well, that can't be possible because you have to define what the chicken language is. No, I bet you it does mean something. You just have to look at the definition of the chicken language. Chicken programming language. Instead, you get this like kind of like it's the same thing as like Klingon. Oh, here's a scheme implementation of chicken. Here's hello world in chicken. All right, so let's see. This is code. This is hello world in chicken. But the thing is that each of these lines corresponds to a magic trick. The number of chickens that is there is like, this is magic trick 14. I'm just guessing at what the number of chickens are in that line, but that's what it comes down to. So if you have, so the very last thing is an empty line with 0 chickens. 0 chickens means exit the program. 1 chicken pushes the string chicken onto a stack. 2 chickens is adding something. 3 chickens is subtracting. 4 chickens is multiplying. 5 chickens is comparing. 6 is load. 7 is store. So it's like an assembly language. So we're loading, we're storing variables, things like that. 8 is jump. 9 is a char. But it looks like they actually have, they've upgraded the language since last I worked with it. Because now they've actually given you, instead of me having to write an interpreter, if I want to have 0 chickens, I just can write the word X. And then this last one, if you have any more than 10 chickens, this pushes the literal number n minus 10 onto the stack. So if I want to push the number 1 onto the stack, I do 11 chickens. 10 says push, 1 is the number, the value I want to push onto the stack. The number 3 is going to take 13 chickens.
Somebody is really smart and they use it.
They used it to do what?
They use it to do.
Well, this is not hard. Everyone in this class can do this. You can. You're just making, you're just looking at it and saying, this is so cryptic that I don't know what's going on. Where everything we've learned in this class is harder than this. It absolutely is. This is just trivial. This language knows how to do 9 things. And then this last thing is just, hey, if you want to store numbers. You want to store a number, you put chicken 10 times, and then the number of chickens for the number you want to store. You want to store the number 7, 17 chickens. And where does that put it? It puts it onto the stack. How do I get stuff off the stack? Top of stack points to the address. Here, add 2 top stack values. So all these operations work off that stack. So you don't actually create variable names. You instead push things onto the stack and work with them off the top of the stack, pushing the result back onto the stack. So all your memory is the stack to remember crap, and then compares your if statements. Yeah, this is not difficult. We could have made this language. Could have. Go ahead.
So if you were to copy the example hello world, if you were to copy that line by line, would it scheme for the world?
Well, no, you would need, well, okay, you're going to answer that question. Tell me why the answer is no. Who knows how to run this code?
No one.
No, that's not true.
Well,
What tool would you need to run that code? A chicken interpreter. An interpreter knows how to run chicken code. Just like we've written an interpreter that knows how to run no code. Make sense? Our language is one thing. This is effectively the grammar for this language. So even though this started off as kind of a joke, this is very germane to this class. And it's actually funny because this looks like an extreme example, right? It's like, oh, this seems to be from left field. Who made this stupid made up language? No, it's real. It's not practical. So when I wrote in this, I had, because now it looks like they have shortcuts. If I want to exit, I just say the word X. So you could actually write your code in significantly fewer number of chickens, where the only time you need to write a whole bunch of chickens is when you're storing literal values. You could have to store the value plus 10 number of chickens. So maybe I write a little interpreter, like a little program, where I type in the number I want to, I want to say, and it outputs that plus 10 number of chickens. You could write that function in Scheme. Right?
What's the benefit of pushing the string chicken? onto the-
Well, because you might need that as a function call later. You might push 2 chickens onto the stack and later on be able to consume it as an add. Because chicken is part of a function call. So this pushes the string chicken onto the stack. Oh, let's look at this. So add the 2 top values. You probably can't do math with chicken. Subtract, multiply, compare 2 top stack values for equality. Store. Top of stack is a relative offset to jump to. So if you barbecue the top of the stack, you end up converting it to ASCII and pushing the result. So your question is what does pushing the string chicken onto the stack do? I can't do math with it. Oh, well, can you? Well, this just pushes a number, so that's not going to be a number of chickens. That's going to be a number. Top value can't do compare 2 top. You can compare chicken to chicken with a compare. Just pick something from the stack. This is a jump, so you can build a loop in this with what is this, like supposed to be fry? I'm guessing you could push things onto the top of the stack, push a number of chickens onto the top of the stack so that you can then use your jump to pull things off the stack to make that number of chickens ultimately equal one of our magic tricks. I can't come up with a good example why we'd want to do that, but you could do that.
So like, if chicken was like down here on the stack, you could jump 2 chickens.
No, you'd have to pop to it. So this thing right here, where's my jump? So 8 chickens would allow me to, so if I do a fry, if I fry my chicken, I I can take the top of the stack and jump to a new location based on the number of instructions. But I think I would still be popping off the stack. I would then have to push. So this probably has a temp stack. All right. Homework. I'm not giving you chicken for homework.
Definitely not.
I did. It's actually would be a good question. So homework is to make our let work as a let star. Remember, let star allows you to define variables in terms of other variables defined inside of the same local environment. It's not gonna be hard. Expand our implementation of let to support the features of a let star, which allows you to define variables in terms of variables defined previously in this let. Example, local vars A2 BA like that. To give you a 2. Make sense? All right. I will see everybody on Tuesday. Nope. Did I not do that? Oh, it's true.
He was about to, and then.
All right, what does this code do? Updated call to be cleaner with a let. Later.